I'm Garrett Ryan, and this is Told in Stone. Today we'll discuss Roman bridges, their construction, their incredible durability, and their capacity for supporting even the heaviest modern vehicles. The first Roman bridges were wooden. The oldest bridge over the Tiber, the Pons Sublicius, was not only made of wood, in keeping with an ancient prohibition, it didn't contain a single nail. Wooden bridges were also built by Roman armies on campaign. During the Gallic Wars, Caesar threw a bridge over the Rhine in only 10 days, supported by pairs of tree trunks pounded into the river bottom with primitive pile drivers. The armies of the imperial era carried ready-made pontoons in their baggage trains. On reaching a river, the men carried light boats to the bank. One by one, these were launched and anchored with baskets of stones. Once they had been lashed together, a deck of planks was nailed over their gunwales. Using similar methods, Caligula assembled a bridge of boats 3 miles long over the Bay of Naples. There were permanent wooden bridges across the empire, especially in the northwestern provinces. The original London Bridge was made of wood. So was the deck of Trajan's gargantuan bridge over the Danube. The massive beams of the Roman bridge over the Rhone at Geneva were so solid that they lasted until the 16th century. Most Roman bridges, however, were stone. Nearly 1,000 still survive in whole or part, and hundreds more have vanished. Although these bridges varied in scale, the techniques used to build them were broadly standardized. If a bridge had more than one span, the first task was to lay the foundations of its piers. Around the Mediterranean, where rivers are often dry in the hot months, builders waited for summer. But if a river flowed year-round, cofferdams had to be constructed. A double row of logs or planks was driven around the site of each pier and made watertight with compacted clay. The space within was drained with screw pumps or water wheels. The newly exposed riverbed was cleared down to bedrock or hard clay. If these proved too deep to reach, the ground was stiffened with pilings. On this base, the bridge piers rose. Usually, they consisted of huge stone blocks clamped together with iron. The thicker the pier, the greater its stability, but to avoid restricting the river, Roman builders tended to make piers only about a third the width of the arches they supported. Most of the arches in Roman bridges were semicircular, which often had the effect of elevating the bridge deck high above the roads at either end. To avoid this, some builders experimented with flatter, segmental arches. Whatever their arc, the arches were normally made of heavy blocks laid over a falsework frame until the keystone was slotted into place. From the late 1st century onward, stone was supplemented and sometimes replaced by brick and concrete. The most spectacular Roman bridges date to the early imperial era. During the reign of Augustus, the Via Flaminia was carried over the river Nera on 4 soaring arches. The largest, rising more than 100 feet above the water, was 105 feet wide. The Pont Saint Martin, still perfectly preserved, has a single span of 120 feet. The Roman bridge at Merida, Spain, has no fewer than 62 arches, and extends a half-mile over the floodplain of a meandering river. Even this was dwarfed by Trajan's bridge over the Danube, whose 20 towering piers supported a deck 3,700 feet long. Ancient pedestrians and vehicles were comparatively light. By far the heaviest load a Roman bridge carried was its own weight. But since the Romans lacked any scientific method of modeling stresses, they tended to build conservatively and made most of their bridges far stronger than they needed to be. A remarkable number of Roman bridges carry modern traffic. As of 2019, for example, the famous bridge at Alcantara, Spain, built during the reign of Trajan, was crossed by 250,000 vehicles every year. It shows no signs of failing. Nor does the Pont des Marchands in Narbonne, which has supported a neighborhood of multi-story shops and houses since the Middle Ages. The blocks that made up the arches of a Roman bridge, the voussoirs, were locked together in compression, transferring the force of their own weight and the loads placed upon them to the abutments on either side. The load-bearing capacity of a bridge depended both on the solidity of its abutments and the strength, shearing point, of its voussoirs. Since Roman builders carved voussoirs from the strongest readily available stone, their bridges tended to be impressively solid. The bridge at Alcantara, which has been subjected to close structural analysis, is a good example. Its 6 semicircular arches are made of local granite laid without mortar. Besides pockets of gravel packed between the arches and the roadway, the rest of the structure consists of the same material. Despite damage from several wars, the bridge remains structurally sound. By one estimate, its largest span is still capable of supporting 57 U.S. tons. Thus, although the Alcantara Bridge would probably buckle under the weight of a modern freight train, it could handle even the heaviest trucks on the American highways, which have a maximum weight of 40 tons. There were few complexities in the design of Roman bridges. They were supported by the pressure of stone on stone and anchored in place by their own weight. But despite the corrosive action of rain and frost and the scouring force of floods, many bridges have defied the centuries and still carry the roads that led to Rome. I hope you enjoyed today's video. If you'd like to watch my new series, Roman Review, where I recently discussed the infamous movie Caligula, head over to my Patreon, which is linked on screen and in the description. If you'd like to see some Roman bridges for yourself, you can join my upcoming trip to Italy, also linked in the description. And if you just can't get enough Told in Stone content, scroll a bit farther down in that description for links to my other YouTube channels. Thanks for watching.